All right, welcome everyone. Thank you so much for joining today for Rooftop Snow Retention. This is presented by Mindy from TRA Snow and Sun. We are going to do a quick little intro about Acelab, show you how to find TRA Snow and Sun on Acelab so you can explore their products, save them to your projects, and get in touch with their team if you've got some questions after today's event. So Mindy, if you wouldn't mind stopping your screen share, I'm going to pass it over to my colleague Helen to do a quick little Acelab intro, and then we'll get started with today's event.
All right. Share this. Y'all see my screen?
Not yet.
Oh, it looks like it's loading there. Now?
Cool.
Yes.
Okay, cool. Sounds good. A little delay there. Hi, everyone. I'm Helen, and I am the Director of Architect Experience here at Acelab. My job is making sure y'all as architects and designers feel supported and have everything you need on the platform. So in that vein, I'm going to go over a few things today. First and foremost, once y'all complete this webinar in the next 2 days, myself or my teammate Evelyn, we will be creating conversations for you within Acelab. So you'll log back in, you'll come over here, we're going to create a project for you, and within that a conversation to ask Mindy directly any questions you might have. That's where we'll be following up with the product literature and all of that information as well. So keep an eye out for that. You'll get an email saying, we have a new connection, and you can now respond directly to that email, and that will create that conversation or kind of keep a record of it also in Acelab. Cool new function that we've launched for folks. So also, if you want to get in touch with Mindy here, you can type in the brand name here, make sure we have brands selected, similar to, kind of shopping on Amazon. And then scroll on down, we're going to see TRA Snow and Sun, click that. And then here we are going to see, another way for y'all to directly contact Mindy, who is great. And then a bunch of information here, and then all of the products that they make as well. So what you can then do here is, if you hear about something today that you are really interested in, you can save this into a project that you can create, or your general research folder. Everyone has one of those. So that's a really great way to just start to create a catalog of like, hey, for this project, here's all the products we want to use, including X, Y, and Z from TRA Snow and Sun. You'll also see some additional information down here that can be helpful for you as well. So lots of good stuff here. Encourage you to check it out after the webinar. Last thing is that I was just speaking about building out your projects in Acelab. I'm going to jump into a tab here, and I'm just going to pull out an example of different ways you can use Acelab. So you can do this on a project basis, where you could, save TRA Snow and Sun, a bunch of other stuff, project specific for your firm. But I've also created here an example of like a sustainability library. So kind of, a run of products that are a little bit more sustainable than maybe what you see otherwise. You can also do this as a firm library. So, hey, we don't always need bird-friendly glazing. When we do, this is what we like. So this is kind of all where Acelab is, and where it's heading is we're going to be able to have schedules and specs generated from all this information as well. So just showing you as an example here again, here's some more sustainable products, so you can build this out, invite your whole firm in to have access to this. If y'all want to talk to me about ways to kind of set yourselves up for success with Acelab, I'd love to meet with you. It's about 15 minutes. And then the other thing too is that we are offering to do libraries for folks right now, and that will allow you to take advantage of that functionality that's coming out in the next 2 months or so. Again, you'll be able to just generate a schedule and also a spec planner. It's really exciting, and we'd love to help you get set up. And with that, I'll pass it back to Mindy. Thank you so much.
Awesome.
Sounds great.
All right. Feel free to answer yes to that poll if you'd like to set up a quick demo. Few quick housekeeping things from me. We'll have some time for questions at the end of today's webinar. Feel free to submit those to the Q&A throughout today's presentation. If we don't get to your question, we'll have a record of it so we can follow up after today's event. We did ask for AIA numbers upon registration. I will also send over a form in the chat momentarily in case you're worried you didn't submit it there. You can give it to us through that form. All right, that's it for me. Mindy, whenever you're ready, feel free to take it away.
Absolutely. Are you able to see my screen?
Yes, yeah.
Perfect. My name is Mindy Dahlquist. I am the Business Development Manager at TRA Snow and Sun. I have been with the company for almost 3 years now, and my goal is to focus on education of rooftop snow retention. So we're going to dive straight in. So this is an AIA certified course. The material that is contained in this course is something that we have researched, assembled, and produced by TRA Snow and Sun. So if you have any questions about the information or a specific project that you're working on, that you think there may be some kind of different situation that's going on there, definitely let us know. And I'm more than happy to take a look at that or pass that on to one of our engineering team members as well. So this course is going to provide a review of the problems, safety issues, and solutions that are associated with heavy snow and ice moving on the roof. We also will touch base into the engineering and installation of snow retention systems as well. Currently, at this time, there is a major gap that's created by the absence of codes and standards relating to any type of rooftop snow retention. So that does create some issues. So we'll touch base onto some of those things. But at the end of this course, you'll be able to realize that those codes and standards are non-existent, even in areas where they are necessary. You'll recognize some of the common hazards and damages that are caused when heavy snow does move on the roof. Hopefully after this, you'll be able to drive down the road if you live in a very heavy snow area and notice some of the damages that have been caused by the snow instead of, oh, this person's chimney has been damaged. You'll now notice, okay, that snow has pressed against that and that's what caused that damage. You'll compare and contrast everyday solutions and design practices, what works and what maybe doesn't, and understanding what modern snow retention systems look like and how they can function. Once we're done with all of that, we also will take a look into the engineering, what needs to be considered to engineer the snow retention devices themselves, and then also the layouts, which are going to be very, very important. If we have a little extra time, sometimes we do, sometimes we don't, we'll touch base on eliminating ice dams and some practices that can be utilized for those. So we do not have volume on the videos that I can share with you, but these videos are still very important to be able to see. So I'll just go ahead and play this now. This just shows how much damage that snow can do once it falls off the roof. So with that, you can see that we are talking about heavy snow. So this is the dramatic side of things. This is going to be in Lake Tahoe, California, which I just heard that they got another 2 feet of snow this past weekend. So it is something that is very serious in certain areas of the country and into Canada and different places. So it definitely needs to be considered when designing in those areas. We're not looking at the light and fluffy snow, not just a little skiff of snow and ice. Although ice sheets can become majorly dangerous on their own, we're going to focus on the heavy snow itself. So when that heavy snow accumulates on the roof, it glaciates. And what that means is it's going to be one giant mass of frozen snow and ice on that roof. So if it does decide to slide off, if the conditions are right for it to be able to move, it can take whatever is in its way right off the roof with it. Just like in this photo, it has removed the dormer from this house completely. These folks will get home probably from work and have to be able to deal with all of that snow that is now in front of their house. The snow gets heavy and hard. It does not stay light and fluffy. Since there are no codes or standards that currently exist for the engineering, manufacturing, or installation of snow retention systems in both the US and Canada, with the building codes being silent, it does result in at least the following that we're aware of, and probably even more that we're unaware of at this time. But currently, snow retention companies can manufacture their systems however they want and out of whatever materials they want. So just looking at my desk here, I have a tape measure. If I wanted to take a tape measure and super glue it all over someone's roof and call it snow retention, at this time, there is no code or standard to say that that is not a functioning snow retention system. Municipalities also have a difficult time codifying snow retention, so they don't have any standard to reference. So in areas where snow is definitely a hazard on the roof, it becomes an issue for the municipality to be able to say you need to have a snow retention system. Well, what qualifies as a snow retention system? Do we just put a bar of snow fence over a walkway, over a doorway? Do 3 brackets work? Do we need 300 brackets? There's no standard for them to be able to reference and say what is an actual functioning snow retention system. And then owners don't want to pay for it, even if it's needed, because it's just not required for them to do. Architects also have a difficult time knowing exactly how to specify snow retention and where the placement needs to be, how much weight it can hold back, all of those types of things. So what are some of the common hazards and challenges that are caused when snow does move on the roof? The most serious one is going to be personal injury and death. And then from there, you'll have damage from sliding snow and ice, premature aging to the roofing material, limited and restricted access and views, and then also ground snow removal. So oftentimes once that snow slides off, it does need to be removed for the property to be functional. And so we'll jump into each of these categories. Since the videos do not play, I'm just going to talk over this slide for a minute and just talk about how serious this is. I have 3 videos here. They're all in different states across the United States, and they are all 3, actually 4 separate deaths within those 3 videos. So this is something that occurs almost every single year. Unfortunately, in 2023, we heard of 2 deaths back to back within the same week. One was a 5-year-old girl in Durango, Colorado, and the other one was a 50-year-old man in Utah here. So it is something that is very serious. It continues to happen. And in each one of these news videos, they call it a freak accident. We believe that it's something that is completely preventable, and there definitely needs to be engineering and facts behind the products that you're utilizing, because oftentimes you're holding back thousands of pounds of snow. So on a lighter note, we will move from the darkness of this conversation, but I always want to kind of definitely bring some attention to that, because we oftentimes do end up involved in these court cases and those types of things, and it's a very sad situation. So other things that can occur when the snow does move on the roof is going to be much less serious than something like that, but can definitely cause headaches and issues down the road within your homes or your buildings. So the sliding snow down this roof has just damaged this dormer. You take that force of that snow, and then it causes some issues as that weight and the force of the moving snow comes into contact with these materials. This is also a double valley, so certain design functions of a home or building can also cause some concerns down the road if that snow does decide to move. So when you're funneling those forces into smaller areas, you have different heights of that snow that's actually sliding down, and when that occurs, it can cause its own damage right there. Penetrations, as we know, are a very easy target to sliding snow and ice. PVC pipe that's used for the plumbing, this oftentimes is actually sheared right off, but metal conduit that's used for electrical wiring penetrations, they can also give way to heavy sliding snow and ice. A lot of times we will see chimneys be pulled off or damaged severely from sliding snow and ice as well. Upper roofs that shed to lower roofs, this can definitely cause serious damage. This photo is a little harder to see, but up towards the top, you'll notice that there's a big dent in that metal roofing material. And then as you get down towards the eave or the edge of that roofing material, it is not supposed to have that little waved pattern that is currently going on. So when snow freezes to the roof, it can also just take that product with it once it does decide to move, and can create a major mess in that fashion as well. Another challenge associated with damage is other parts of the structure besides the roof. So this is a deck enclosure. These are neighboring cabins. They are side by side. They look almost identical. The neighbor's cabin does have snow retention on it. Their cabin does not. The neighbors still has their deck enclosure and this cabin does not. So luckily they will be able to just shovel that snow right off the side of that deck. But unfortunately, it most likely will need to be repaired and has caused some issues. And luckily, I don't believe the snow hit their neighbor's enclosure, but that is something that we see quite often is a house will shed the snow and that snow will either take out their neighbor's fence or their neighbor's solar panels or something of that fashion and becomes quite an issue between neighbors, and it's not a fun situation to be in the middle of. So this image is just trying to show the danger of gas meters. This is something that is taken into consideration in codes and standards in most locations now. But if you're doing any kind of remodel on a building, definitely take that into consideration on where your gas meters are located, that they are not in a shed, snow shed area. This is a situation that did happen in Canada where the snow shut off the roof of a home onto the gas meter. The homeowners went out, took a look at everything. Everything looked to be physically okay, so they went on with their life. And 3 days later, luckily, there was no one in the home at that point, but 3 days later, their home did explode. So that's just something that is very serious and needs to be taken into consideration as well. What we're looking at here, structural damage, something that's not usually taken into consideration is going to be windows. So if your slope of your roof is not steep enough to shed that snow off quickly, the snow sliding off can actually curl underneath. So what's happening is the ridge of your home, so up at the top of your home, you have the majority of your heat loss. And as that heat begins to melt the snow and ice, it does allow that water and snow to come back down towards the eave, and gravity also assists with that as well. The eave of your home is going to be the coldest part of your roof. So that edge of your roof is going to be much colder. So things are beginning to refreeze or have already frozen. And so it's going to be very heavy and frozen there. Gravity's still pulling it down. It continues to curl underneath and can oftentimes result in broken windows. This is very common for us to see and just something that's pretty avoidable. Property adjacent to the structure can also be damaged from sliding snow and ice. So these are two different incidents where cars have been severely damaged. The car on the left, this is in New York City, and the car on the cars, vehicles, all of them on the right, this was a PVC pipe that was utilized as snow retention on this was a motel, and unfortunately the snow retention as PVC pipe did not function and definitely caused some damage. So these were all visitors to this hotel, and they had kind of a rough day, I would say, getting all of that snow and out of their vehicles and their windshields replaced and all of that. So those types of things definitely need to be looked at and avoided as much as possible. This photo just shows how much that snow wants to stay in one piece once it has frozen in that glacial mass. So this light pole was never intended to be a snow retention device, and here it is doing quite a good job at this point. Premature roof aging, this is something that can happen with all those freeze-thaw cycles that are happening on that roof. You're subjecting these materials to repeated expansion and contraction, and then just adding the force of that accumulated snow. If that snow slides, it's then pushing those materials. The same thing can happen on your metal roofs. You have a lot of protective coatings oftentimes or paint on those, and you just have that compacted, crusty snow on your roof. And as it shifts or moves, it's acting just like sandpaper on top of those beautiful roofs. Limited and restricted access. So entrances to your buildings and homes can be blocked by snow that falls from a roof. Last year about this time, it's probably a little closer to winter, I was driving to Montana, and many of the houses that I saw between Idaho and Montana, they couldn't even get into their front entrances because of the snow that had shut off the roof directly into their front doors. And their snow pile is just as high as their entire house structure. So at that point, you just have no ability to get in there until that snow actually melts, unless you have some type of heavy equipment, and then it's still very time consuming. This cabin was built with snow shed in mind, so let's get that snow off of this roof, allow it to shed. Unfortunately, the afterthought there was the beautiful walkway that was designed between the parking below and the large front entrance to the right. And so with inability to walk through your gorgeous walkway for possibly 4 to 6 months out of the year, it kind of takes the joy out of the beauty of the walkway. So always considering if you are allowing that snow to shed where your walkways, windows, doors, garages, all of those things are, is going to be very, very crucial. This is a homeowner who knows that they have a problem with snow shed, and so they've installed crickets on all of their roofing penetrations to help protect those penetrations. And they've continued to have issues over the years of broken windows from that creep and curl that we discussed. So with that, they've installed their own do-it-yourself type barn style window coverings. And with that, unfortunately, it's a great idea in some ways, but it definitely impedes any kind of daylight or views from the outside. And also, they still have a broken window and 2 broken window coverings and a giant pile of snow in their yard that hopefully doesn't need to be moved, or it's going to be quite a mess to handle. Once that ground snow, once that snow builds up and slides off and becomes snow on the ground, it also oftentimes does need to be removed. And that can be costly, time consuming, and also labor intensive as well. And so something that's kind of interesting to note is I actually did plow snow professionally for a little while in my past, and a piece of equipment to plow with was about $350 per hour. So that is something that can be very, very expensive. So there are some everyday solutions: the sign approach, the caution tape approach, and then manual rooftop snow removal. So we'll dive into each one of these a little bit and see if they are actually helpful in the long run. So the sign approach, this is something you'll see almost anytime you go into ski resort areas or some of these little mountain towns, and they will have a sign that simply is put up and says, "Danger, falling snow and ice from the roof." This one says, "Walk well or park clear." The problem with this sign specifically is it is the color of the siding, so it blends right in. Oftentimes these are placed in places that you are not going to notice before there could also be an issue. And when it comes to liability, it does not remove any kind of liability by having this sign up. It basically, to a judge, will say, "I know there's a big problem and I'm choosing to do nothing about it." So this will not stop any kind of damage or injury, and doesn't help in the long run if you run into some kind of court case as well. I was in Durango, Colorado a few months back, and it was not snowy, anything like that, but I was pumping gas. And after finishing pumping gas, I look over at the gas pump and there's a sign that says, "Snow will fall right here." And I look up and I am directly underneath the edge of the awning, to where if there was snow, I was right in that position and wouldn't have even known that that was going to be an issue, mostly by their sign that I had not noticed. And oftentimes these signs are put in very interesting places. So here's your handicap parking spot. You're getting your grandma or your aunt or your family member who is handicap out of their vehicle, or going to lunch with them. And you'll look up and there's a sign that says, "Danger, roof shed, snow and ice," right above the handicap parking spot. So it may be an ADA spot, but at the same time, if you have to possibly run from shedding snow, it is not a safe place for you to be. The caution tape approach is something that in this photo shows very well that tape can be very easily covered by the snow. It also can be ignored, ripped, moved, and it definitely limits access to otherwise usable areas of the property. So if you have a sidewalk there, do you really want to rope off a sidewalk if you are able to stop the problem in the long run? So some do choose to shovel the roof off every year. That does risk damage to the roof surface, endangering those shoveling on top of the roof and also below as well. And this is just going to be very, very costly. OSHA puts out a statement every single year before winter warning about the dangers of being on the roof in winter conditions to remove snow from the roof. It can be very, very dangerous. So just something to take note in, and it's also extremely expensive to have that snow removed as well. This video is just going to show how quickly something can go wrong on that roof in those icy conditions. So this is not in the United States. I believe this man is perfectly okay. And luckily, he works with some paramedics, so they're going to come over, pat him on the back, get him back to work because his lunch break is over and it's time for him to get the rest of the snow off the roof. So, this is just something that needs to very much be considered, that asking someone to get up on your roof and shovel it off year after year is going to incur a lot of cost and also a lot of danger on your property. It puts you liable for the workers that are on your property. And the guy in the middle, I'm not exactly sure what his end game is there. I don't believe gravity is going to be his friend at the end of the day. And then the photo on the right is just showing how many people, how much manpower, how this has to be a team effort to be able to get this snow off of a large roof. And it's just very, very timely. So let's take a look at a few design practices in the US and Canada as potential solutions. As a general rule in the US and Canada, structures are designed with a steep sloping roof in mountainous regions and lower slopes in the lowlands. So steeper slopes do allow for that snow to slide off more easily, but however, the solution is designed specifically around the snow itself and doesn't effectively address the many disadvantages and dangers that we've already just discussed. So Europe has a different design strategy, and it's actually exactly the opposite of what we do in the US and Canada. We're not saying it's 100% right, it's just something that we've come across and learned. So they do choose to use a low slope roof in the mountainous regions to prevent damage to the roof, as well as retain the snow on the roof as an insulating blanket. With that, you're promoting energy efficiency, and by retaining that snow on the roof, you're allowing for even snow melt off, lack of injuries to residents and guests, and property below the roof. You can just avoid all of those damages and issues. You're also limiting liability, and then you're just able to design with so much more freedom. You're not worried about where your entrance is, your walkways, your garage doors, all of those types of things. And then in the lowland areas, they actually use steep slope roofs. They're just trying to facilitate water egress in those situations. So as I just mentioned, you do have less design freedom when you are shedding the snow, and you're also losing the snow as an insulator as well. Dormers are something that I like to kind of just give a little shout out to, whether it was ever intentional or not. They actually do work really well to hold the snow in place or divert it once it's moving. They can minimize the locations that the snow is able to fall and shield those locations, such as walkways and entranceways, to protect people or things below them. They do come with their own list of disadvantages, though. Although they can be very structurally sound and diverting and successful at diverting that snow and shielding those areas below, oftentimes that roofing product isn't strong enough or durable enough to be able to take that weight or forces of moving snow. So your roofing material is not made to take something crashing into it. Maybe a little hail or a little something like that, yes, but it is not made to take the impact of thousands of pounds or even hundreds of pounds of snow and ice moving around on it and slamming into other portions of the roof. So the stormer's done a great job of diverting the snow, protecting the walkway, possibly protecting somebody who is down below. But unfortunately, this roof is now extremely damaged due to that situation. Another problem with the dormers is they do create a lot of areas on that roof that is now going to alternate regularly between sun and shade. So you're just increasing that freeze thaw cycle that can happen, and that can cause issues with ice buildup. And those ice buildup situations can usually create damage or leaks that do often require a lot of maintenance year after year. So, what kind of roofing products are effective solutions? A slippery roof, non slippery roof. When it comes to snow, some roofs are going to be very slippery and snow does move very easily on them. Roofing in that category would include metal roofs, composite and synthetic, eco roofs, and single ply roofs. None of these roofing types on their own will be effective at stopping the snow from moving. And this is just going to be a really good example of this. This is the Dallas, Texas Stadium. It is game day, and they got a little skiff of snow. They don't have equipment on hand oftentimes to handle those kind of snowstorms, so they are using a grader to be able to get the snow off the parking lot. This skiff of snow that slid off the roof did hit 6 people. Those 6 people filed a lawsuit, and they did win that lawsuit. So, an interesting story from this is the Mercedes-Benz Stadium in Atlanta, Georgia, is managed by the same management company. And so it actually has a full, I believe, like 3-4 bar system on that Mercedes-Benz Stadium. So it does have snow retention on it in an area that does not get a large amount of snow, just to mitigate the risk of the same kind of lawsuit that they ran into in Dallas. Other roofing products that are not as slippery is going to include tile and slate, which those actually can be quite slippery, but it still falls a little bit more into this category. Wood shingles and shakes, asphalt shingles, and rock-coated metal shingles. So the tiles and slate, this is something that can be very, very damaged by the snow and ice sliding on the roof, as you can see in this photo. And the wood roofs that aren't just going to be as slippery, but the snow is still going to move, as we can see in these photos here, where there's no longer a deck railing on the right photo and the left, where that damage to the valley and the rake has occurred. Asphalt shingles and rock-coated metal shingles, they are just not very slippery at all. But oftentimes that just makes us assume that snow and ice does not move on those roofs. Unfortunately, that is not true. So oftentimes it's going to move at a different time period than when like your metal roof would shed your snow. Usually it's going to be in the spring, your melting starts to occur. You have water that's now running between the snowpack and the roof. When the temperatures drop at night, that water is refreezing, creating a layer of ice between the snow and the roofing material. It just gives us the perfect environment for that snow to move right off the roof, as we're seeing here. So, in summary, all roofing types do have problems associated with moving snow and ice. There are modern snow retention systems. I don't believe this outhouse has one on it, but it is just a cool photo to take a look at. So the idea of retaining snow on the roof and keeping it from moving and falling off is not a new idea. This is something that has been going on for centuries. Oftentimes it was boulders or logs that were placed on the roof to keep the snow from moving. I always say I don't know that I want to be hit in the head with a boulder any more than a large pile of snow, but you work with what you have. And this is something that has been continuously happening for years and years. So the modern types of snow retention devices are going to be snow brackets. They're oftentimes called snow stops, snow guards, all kinds of different titles for those snow brackets, but for this class, we are going to call them brackets, and then snow fences. Snow brackets lie directly on the roof surface. Generally, they'll cover the entire roof, and they're going to mount to the sheathings, the battens, or the roofing product itself. Where snow fences are a little different, they generally clamp onto the metal roof seam or mount directly to the deck by attaching to the rafters, trusses, purlins, or other structure. So it's very important to remember that those deck mounts do need to go into structure. Brackets are designed to penetrate about 3 inches into the blanket of snow on the roof, and then the snow freezes to those brackets, resulting in one large glacial snow and ice mass held in place by the brackets. So the most important characteristic of snow brackets is that they are designed to stop snow from moving, not to stop moving snow. We'll talk a little bit about partial installation in a minute, but this is something that I really want to draw attention to while we're on this slide, that that they are not made to just have one row of snow brackets along the eave to catch that snow or to chop it up into pieces as it's sliding off. Snow brackets are made to be utilized as a whole system in a staggered pattern going up the roof. So if you look closely, there's a little space between that snowpack and the roof surface. That just allows for proper drainage of the roofing, of the snow on the roof. And then snow brackets are designed for most roofing materials. They are very, very versatile. They can be used with snow fences. I recommend that in very heavy snow load areas. And they have all different, I mean, there's different colors, different shapes, all that types of things as well. So snow fences themselves have little different characteristics. So they're designed to stop the avalanching on the roof. You still want the snow to freeze to the fence once it comes into contact with them, but they're more as the last stop prevention of that snow avalanching off the roof. So snow fences and brackets, as I mentioned, they can be used together. We see some of that in the two pictures on the right, and that just really helps for those shear off situations of the snow where you've got multiple layers. The brackets help that just be frozen into one spot, and then the fences allow for that extra safety protection along the eave as well. If one fence isn't enough, then multiple rows can be used. So that's going to be determined by all of the factors going into your project as to how many rows you do need on your building or on your structure. And the photo on the right on the bottom is the best picture that I could possibly show you for how much snow can be held on a roof. So this is in Lake Tahoe, California as well. That's about, I think, 6 to 8 feet of snow. I can't remember the exact amount on a 2-bar system, and there's 4 rows of that snow retention. This job has been done for years and years, and it looks like this every single year. And it is just the perfect explanation of all of those snowstorms sitting there and being frozen in place. Deck mounts, as I mentioned, they do need to be attached into structure. This is just showing a simple drawing of an attachment into a truss or a rafter, where clamp-on fences clamp directly to the roof seam and hold the fence in place without puncturing through and allowing that snow to freeze to everything. Snow brackets and fences can be used for almost all roof types. They can be made out of various materials: steel, copper, aluminum, and powder coated to match most roof colors as well. We'll jump into the engineering, and if I talk really fast, there's a lot of information here. I have a lot to share, so I just want to get through this. But if there's any specific slides or something like that that we need to touch back base on after this, just contact me and I have no problem sharing as much of this as you'd like. So engineering of snow loads on the roof. So how much additional weight is being held on the roof and retained? We're going to use ground snow load for this. We're holding all of that snow. We're not allowing it to slide off. That's why you are using ground snow load. And then, are the buildings strong enough to handle that weight of the snow? So snow loads have been part of the building code since the mid 1970s. They should be designed with snow loads considered. Anything built prior to the mid 1970s, do not go putting snow retention on a historical building without checking it out with a structural engineer and having that approved before installing snow retention. That is just not something we want to see happen. We do not want those historical buildings to be damaged by trying to hold more weight than they were ever designed to hold. So some of the factors that do need to be considered while engineering these devices or these systems is going to be the roofing product and how it's secured. How strong are the fasteners? How thick is the sheathing? What is the force of the snow on those retention devices? What is the weight of the entire snow mass from eave to ridge? What is that roof slope? And how strong is that individual snow retention device? Some of this information you may know about your project, and some of it cannot be looked up. So in Durango, I had a architect tell me that they allow their roofer to engineer their snow retention system. And I am suddenly concerned because a roofer can look up the ground snow load, the slope of the roof, the roofing material, the sheathing, and the rafter truss spacing. But since there are no codes or standards for snow retention systems, there are some things that cannot be looked up or determined, such as what is the strength of this snow retention device? What is the pull-out strength of the fasteners that you're using once they're installed into that specific roofing material, and then also into that specific sheathing? What is the fail point of the system? So if a snow retention company is not testing their products and systems and all of those details to be able to have that data that's needed to engineer those snow retention systems, then you most definitely can see failures. We're going to go past the testing of that because I don't believe I want to spend any more time on that part of it. These two graphs just show exactly how much each one of these factors matter. So on the left, we're seeing 7/16 wafer board. On the right is 3/4 inch CDX plywood. These projects are exactly the same. The only difference between the whole entire projects is the sheathing that the snow retention will be installed into. As you can see on the 7/16 wafer board, we're looking at 23 brackets per roofing square. On the right, on the 3/4 inch CDX plywood, it is 11 brackets per roofing square. So if you have two projects side by side and you're like, we're just going to use the same snow retention layout, please do not do that. I mean, we offer them for free. I'm sure many of our competitors do as well. It is something that you could be overselling the client, double the amount of snow brackets that they need, which is unnecessary and an unnecessary cost in the budget, or you could be selling half as many as is actually needed, and you most definitely could see failures on that project. So brackets are spaced on the roof from eave to ridge in a staggered pattern. The dimensions will definitely change with each product and with each project, sorry. This is an example of a snow bracket layout. This is an example of a snow fence layout. In some areas of this roof, one fence was needed. In other areas, there were 4 fences needed. So if a snow retention is not engineered for all of those variables, you definitely can see failures. Plastic brackets, I'm not going to dive into this too much. Plastic brackets, I will say, they are installed on the pediatrician's office of the pediatrician that I take my children to, and they are the perfect lawn ornaments all across the landscaping because they do not stay on the roof. There's a million reasons that adhesives can fail on your roof. It's a very hot and cold situation that occurs on your roof, and plastic just does not do the best, and neither does the adhesive that's on the back of those brackets. Retention devices themselves, made out of steel, can be very, very strong, but without proper engineering and installation, they can fail on various types of roofs. So these are all unengineered systems. The far right is the best example of why that upper roof should not shed directly into the lower roof, even if you have snow retention. One of our biggest design rules in snow retention for us is not allowing for stops throughout the field. So you cannot terminate the snow fences mid-field. So that far right is the perfect example of that. You can see all of those fences have failed completely because that run did not continue. It may have also needed multiple rows, but the snow sliding into those areas, it's frozen into one mass and can just push those fences out of the way. This was a do-it-yourself situation. These are 1/4 inch plate steel snow brackets, and these were installed on the eave of the roof. As I mentioned, brackets are not made to take that impact, and so they actually ripped the sheathing right out of the roof, which is not a fun thing to clean up after, I would imagine. The left photo, PVC pipe has never been intended to be a snow retention device, and the photo on the right just shows a deck mount fence system that has been installed poorly. So this is not going into trusses or rafters. This is only being installed into the roofing material and the sheathing. These screws will not be able to penetrate any further than that, and so you just have way too much weight being pushed onto those tiny little screws in the wrong position. So the partial installation, I think I've touched base on this pretty well, but it is the biggest reason that we have ever seen any kind of failure in any of the manufacturers of snow retention. If you are partially installing snow retention along runs of the roof, you most likely can see failure. So this is a perfect example of that. What you have to remember is that snow mass is all one piece. And as you allow that last seam of that snow retention to hold the weight of the entire rest of the roof that is not covered in snow retention, those seams are not made to hold that kind of weight on their own. So you're just allowing those last little few to just struggle until they eventually can no longer hold anymore. This is the same example. This is a homeowner. This has all been taken care of and handled for them, but they had snow retention along the front and decided to cover this gutter. That did end up causing them some issues because the whole run of that roof was being held on those 4 final seams. The upper roof shedding to the lower roof, I've mentioned this, and this is just the perfect picture to show that off. It's about a 1.5 foot gap from that upper roof to the lower roof, and it has still crushed a large amount of their roofing material. Oftentimes, those are not even noticed until it is too late. How often do we get up on our roofs and check them out? Not as often as we should. So I do have a little bit of extra time. I'm going to very, very quickly run through this because I would rather take some time to answer some questions. The owner of our company has done some work with eliminating ice dams, and he wrote the manual for the cold roof systems, co-authored that. And so we have a little bit of additional information on how to help eliminate ice dams. Ice damming is caused by that heat difference and that cold difference on the roof that I discussed earlier. You just have the ridge of your home where it's very, very warm. As you get out towards the eave, it's refreezing. The water is coming behind it, and that water has 2 options. It either backs up behind that ice dam that has started, or it runs out over top of it as icicles and continues to build that ice dam. These are very good examples of extremely large, messy ice dams that you do not want to see on your property. So in Canada, as I mentioned, they do things a little bit differently to help eliminate ice dams, and that focuses around these key points. They use the low slope roof in the mountainous regions. It's just easier to hold the snow on a low slope roof. Kind of common sense on that one. But then they also are equalizing the roof's temperature to the outside ambient temperature by utilizing a ventilated roof system. With that, they're using a large volume of equal amounts of air from eave to ridge, and they're incorporating more insulation with a greater R value. So with that, they're utilizing a minimum of R50. So in some areas, this is going to be complete overkill. I know a lot of eastern areas, Midwest areas that do not go over R30 for just about any reason. But if you're having issues with ice damming and you're in a very cold, snowy, mountainous climate, this is going to be a good thing for you to be able to look into. And then they're holding snow on the roof with that snow retention system, creating that insulating blanket. The photo on the left will show what a traditional roof system looks like, where the photo on the right is going to show what that cold roof system does depict. So something that's very important for the codes and standards of a cold roof system, it actually calls for like 1/4 of the amount of air that you would actually need to move from eave to ridge to be able to equalize the temperature of your attic to the outside ambient temperature. So if you're unable to take the temperature on the inside and it's the same as the outside, then that is technically not a cold roof system. So I'm going to skip past some of these things. This is just an example of what the cold roof system does look like with a snow retention system in that right photo there. This is a vented roof with a full snow retention system on it. They obviously knew they had a problem in the left photo. And so these buildings are about 100 yards apart in Sun Peaks, Canada. And in that left, I can't imagine staying somewhere and you open up your door and you're faced with a 7-foot icicle or 12-foot icicle, however large that is. Kind of scary, and probably kind of concerning down below as those fall as well. So I've touched base on all of these things, how to stop damage to the roof from sliding snow and ice, allowing safe access all around the buildings, providing even distribution with the weight of snow and ice by using that snow retention system, even snow melt off, creating that insulating blanket, and providing more architectural freedom. So that does complete the AIA portion of my course, I would like to kind of jump into the free engineering and things that we offer, if that's okay, Bo, or if you would like to jump into questions. Either way, I'm fine.
Yeah, no, go for it. You can jump into the things that you offer, and then we can move to questions.
Perfect. So TRA and Snow and Sun has been in business for 30 years. This is our 30th year. We started, the owner of our company started in the tile roof industry and had sold a large amount of tile roofs. Once he no longer worked for that company, he was called as a consultant to come figure out why the snow was busting up those tile roofs. So our company started as tile roof accessories. So a lot of his education came from Europe on how they handled snow and snow retention. And he came back and designed his own snow bracket. And now we are still in business 30 years later and better than ever. So we really focus on the engineering of snow retention. We do this for free. We are able to recommend products for you. This is an example of one of our snow fence layouts. This is an example of a bracket layout. We do offer guide specifications for all products, data sheets for all products, and a system warranty that is a lifetime warranty to replace the product if, as long as it's installed per the layout. If you would see any kind of failures, things like that, obviously we would hope not, but that is something that we stand behind. We are still a very small family business for the amount of work that we do out there. I believe when I started here, we were about 20 employees, and now we're like 35, 40. And so we are growing, but we still have that small family feel. And we're working with the ASTM task group to try to develop some standards so there isn't so many questions and concerns and unopened reasons to be able to design for everyone in snow retention. So hopefully that will come out with some more things down the road. Terry Anderson, the original owner and founder of our company, he is still doing roofing consulting for more serious roof issues. So if you're trying to design a cold roof system or you're trying to deal with major ice damming problems, he is an absolute expert in that. I believe he's been in the roofing industry for 45 years at this point. So any things like that, any way we can be of assistance to you, even if it's not a layout for snow retention, we are more than happy to help in any way possible.
All right, awesome. Does that wrap up your portion at the end?
Yes.
Perfect. Okay, so let's jump into some questions. And I also want to let folks know, if you have a question that feels like it would be easier to ask out loud, feel free to raise your hand. We can unmute you and you don't have to turn your video on. But yeah, if you have one that feels like longer winded or a bit more of a discussion, feel free to raise your hand and I'll keep my eye on that. All right, so we're going to start off here. This one looks like more of a comment, but from Patrick, please note that low sloped roofs in high snow locations have to have heavier structurally designed roof systems to retain snow over time for additional insulation.
Absolutely. And something that needs to be considered there is whether you have snow retention or not on that low sloped roof, it is oftentimes going to retain that snow on its own for a very long period of time before it slides off. So that structural consideration needs to be taken whether you plan to install snow retention or not on that structure.
Mhm. All right. Can you repeat the information on snow loads and what's required?
So what we utilize is going to be the ground snow load. So that is just because using a minimized roof load is something that is taking that snow and allowing it to slide off and considering, okay, if it's this percentage of a slope, then it is going to minimize the amount of snow that is on the roof. But unfortunately, when you're holding the snow on the roof, you're not minimizing any of those loads. So ground snow load is the safest option. We engineer to worst case scenario, and we surpassed worst case scenario last year in Utah. We had higher storms than we had ever seen. Luckily, we didn't see any issues or concerns from that, but it is something that making sure that you're not taking away from the structure to be able to cut corners or save money is very, very important, that you're utilizing those heavier snow loads and utilizing ground snow loads when you're using any kind of snow retention device on the roof.
Awesome. Do you offer crickets or braces for events and flus?
No, we've never really got into that kind of issue with us specifically, like not issue with us, I guess, but we've been asked often, I guess, and it's just not something that we don't have the product for it, I guess. A lot of times they're more thinner gauge material. It's going to be more aluminum, those types of things that are utilized to create a cricket. We have oftentimes put up snow fences around those areas, or contractors have used snow fences around those areas, or brackets. But if you're utilizing brackets in just a cricket type of formation, you want to make sure that it is breaking away at a 45-degree angle so that you are not pulling those brackets out. It's allowing for that break off of the snow.
Mhm. All right. How does ridge vent work? Does it get covered by snow?
So yeah, it would be, I mean, your top ridge vent oftentimes would be covered by snow, but if you're venting for a cold roof system, you're not only venting specifically at the ridge. You would have intakes, and so those intakes would be where that snow is actually not going to be. And then anywhere beyond that would be the same temperature as outside. And you should have enough movement of snow in those scenarios where you're not having a full cover and the air is still able to get through. I am not the expert on cold roofs. I don't pretend to be. So if you have any specific questions that way on a project that you're working on, I definitely can put you in contact with our owner, and he would be more than happy to talk to you for as long as you'd like and answer as many questions as you'd like about cold roof systems.
All right, and looks like this might be our last one, so I'll just put in another call for any other last minute questions. Feel free to submit them now so we can get to them. But from Bob, does your company offer third-party delegated design engineering stamped documents for design and layout of snow retention?
Yes, so we work with a local engineering firm here called Vector, and we have all of our designs. They have been able to go over our structural notes and all of our strength values, all of that, and they have stamped all of our calculators for that. And then we also have, if you need like a wet stamp for a project, it's usually always kind of think that it's going to be at least about $1,000 extra for that wet stamp. And then we usually work directly with Vector, or if you have an engineering firm that you have of choice, we're more than happy to work with them to make sure that that wet stamp is available on that project for you.
Awesome. All right, and from Patrick, just a thought with original building design. It appears best to design building entrances away from roof slope shedding areas and keep walks and parking away from buildings a correct distance.
Yeah. But that oftentimes, I mean, we need to be able to park and walk and enter
Mhm.
somewhere. So our roofs oftentimes do kind of hit those same areas. So it's very difficult to be able to design on where your snow is going to shed and where your kids are going to play or where your dog is going to decide to use the bathroom. So that's why
Yeah,
it's a very, very important that there's lots of considerations if you are shedding heavy snow.
yeah, definitely. All right, it looks like that has wrapped up our questions. So if anybody does have another question that comes to them, there will be a quick survey after you leave today's webinar. Feel free to enter any questions or comments there. Super helpful for us if you can take a moment to fill that out when you're leaving today's event. Other than that, I just want to thank everyone so much who attended today. Thank you for all of your great questions. We really appreciate you coming out and being so engaged. And thank you so much, Mindy, for an excellent presentation. It's always lovely to have you.
Of course. I was worried about time, but we did it.
No, we did great. We are right on time. And looks like we'll even give everybody 2 or 3 minutes back in their day. So that's always nice. All right. Awesome. Thank you so much, everyone. Have a good rest of your day.